Alright, so in this section we're going to start looking at sine and cosine as functions, or looking at their graphs. And so when we look at sine and cosine, we're going to get the graphs from the unit circle. And so when we look at sine and cosine as functions, we plug in angles to sine and cosine, and then we get out an x or y coordinate from the unit circle. And so it's really not anything different that we've been doing. We're just going to look at some specific angles and see what, if we graph those points, what the graphs of sine and cosine will look like. Alright, so I'm going to graph on this grid. I'm going to graph, I'll make this a little smaller. I'm going to graph the graph of sine. And so I'm going to graph this y equals, I'm just going to graph the basic sine function. Y equals sine x. Now, if I were to plug this into the calculator and look at this graph, I'm only going to label it from 0 to 2 pi and then from 0 to negative 2 pi. But you can tell when we graph it, and I'm going to graph it on here for you so you can see what'll happen, is it really goes out further than that. So the graph never ends. It actually is going to keep going to the left and to the right forever. And so I just want you to see what that's going to look like. If this will ever come up. Alright, and so all I did was I went into y equals and graphed this sine x. And so here's my graph. And so you can see that it keeps going forever. And if I trace 2 pi is actually right here. So the graph is going to keep going for as long as it'll go. But we're just going to look at the main points and what's called one period of this. So I'm going to look at the unit circle to do this. And so when I start out, I'm going to always start out at 0. So if I plug 0 into sine, the sine at 0, remember sine is y, so I'm going to go to 0 on my unit circle and look at what the y coordinate would be, and that's 0. So my point there is going to be 0, 0, so it's going to go through the origin like this. So there's my first point. Now I'm going to go out here to pi over 2 and see where that's going to go. So I'm going to look at the sine of pi over 2 on my unit circle. Pi over 2 is here, so the sine, or the y of that, is 1. So at pi over 2 I go up to 1. Alright, so at pi over 2 I go up to 1. I'm going to look at pi, and so at pi I go to 0, the y coordinate. So it goes back through the x-axis. At 3 pi over 2, that's going to be negative 1. And so that point is down here. And then when I get all the way back around the unit circle at 2 pi, the y coordinate is 0. And so then if I go around the unit circle in a positive direction, this is what my function normally looks like. Now I'm also going to graph this to the left. And so to do that, remember we get negative angles. Instead of rotating this way, we're going to rotate down in this way. And so that's going to give me negative angles. So I'm going to start, I've already got the point at 0, that's 0. So now I'm going to go to negative pi over 2, and that would be like this angle right here. So at negative pi over 2, my y value would be negative 1. So it's going to go to negative 1 here. And then at negative pi, that would be right here. My point would be at 0. So back through the x-axis. At negative 3 pi over 2, that's going to be up here, which is 1. And so then all the way back around to 2 pi is going to be back down at 0. And so then my negative period, or my negative side, looks like that. And so this is what the basic graph of sine looks like. And sine, if we've done nothing to it, if we haven't shifted it up or down, left or right, or changed the period, and I'm going to show you what that is in a second, then sine is going to go through the origin. So sine goes through the origin. Okay, and so that's at 0, 0. Now, it's always also going to go up to a max first unless we flip this, okay? So remember back to Algebra 2 when we had graphs like this. X squared looked like this. But we changed it and made it look like this when we stuck a negative out front. So that's going to be the same thing that happens with sine. If we were to stick a negative out front, instead of it going up first and then down, it would go down first, then up. And so we'll talk about all of those transformations in a little bit. Now let's look at the graph of, I'm going to make this a little smaller. Now let's look at the graph of cosine. And cosine, we're going to get the points the exact same way. Okay, cosine goes with the x coordinate. And so I'm just going to go to the unit circle, and instead of getting a y coordinate, whenever I look at these specific angles, I'm going to look at the x coordinate because this is cosine. So at 0, when I'm at 0, cos x goes with 1. So 0 goes up to 1. At pi over 2, I'm going to go to 0. So through the x-axis. At pi, I'm going to go to -1. And then at 3 pi over 2, it's going to be back at 0. And then at the end, at 2 pi, I'm going to be at 1. So I'm going 0 and then 1. So 0 right here, and then 1 on the end. And so then my positive side of cosine looks like this. And then to go to the negative side, I'm just going to go back around the unit circle in the opposite direction. So down here, if I go to negative pi over 2, x is 0. So that's there. If I go to negative pi, that's around here, x is -1. That's going to be down here. At negative 3 pi over 2, x is 0. And then all the way back around at 2 pi, x is going to be 1. And so then my negative side looks like this. And so one of the things you need to note is that cosine will start. And when I say start, I mean the first point at 0. So at 0, it's either going to go up to a max or down to a min. Okay, cosine, when I say start, I'm not talking about out here to the far left. I'm talking about right here at 0. So what's it doing at 0? So at 0, it's going to start either at a max or a min. Okay, and so it's going to start at a max if we just graph the regular cosine. If I were to put a negative out front, that would flip this and it would start down at a min. Alright, and so now the domain of both of these, we said that they would keep going forever to the left and to the right, and so we can plug anything into sine and cosine. Graph is going to go out forever. So the domain is going to be x can belong to the set from -infinity to +infinity, or we could write that as x belongs to the set of all real numbers. So we can plug anything into sine and cosine. And so by looking at our basic graphs, we can see that the range of both of these functions, if we haven't done anything to it, if we don't stretch it or anything like that, then the basic functions have a range. Remember, range is the lowest point to the highest point. And so both of these, the lowest points are at -1 and the highest points are at 1. And so we actually have points that hit that. So when I write my range, I'm going to say y belongs to the set from brackets -1 to 1. And remember, we want brackets on there because we want to include these points. And so now both of these functions are called periodic functions. And periodic functions, basically, down here, the definition, functions are called periodic when they repeat for some values in the domain. So when we look at these functions right here, if I were to keep graphing this was me going around the unit circle one time. But I could go around the unit circle again and get another cycle of this graph. And so they're periodic because they're going to keep repeating themselves over and over. And that's basically all a periodic function is. This is just a fancy definition. So the period of a function is the smallest amount, and I'm going to talk more about this in a second, is the smallest amount along the x-axis it takes for the function to make one full cycle. Okay, so the normal period, and we looked at this on the calculator too, one full cycle is going up and then down and then hitting the x-axis again. So it's got to make a mountain, then a valley, and then when it starts repeating that, that's one period. Okay, so at this point right here at 2 pi, that's what we trace. And over here, if I were to keep graphing after this point at 2 pi, it would start repeating. And so I just want how long on the x-axis it takes to make one full cycle without repeating itself. And so that's what the period is. And we're going to look at finding that for different functions because we can change the period as long if we transform it in some way. So we're going to begin using the period to help us graph these. And so all of the functions that we're going to graph are going to be in this form. A sine bx minus c plus d, or cosine. And so each one of these little letters do something to the graph. They either stretch it this way, shrink it, stretch it this way, okay, shrink it, or we can shift it up and down or left and right. And so that's what each one of these letters do, and we're going to look at them individually. And so we're going to look at two letters in this lesson, and so those letters are A and B. Okay, and so when we graph any trig functions, we need two things. First, we need the amplitude, and that's just going to be given by the letter A. And then second, we need the period, which is going to be influenced by the letter B. And so we're going to look at how to find both of these. First, we're going to look at the period, even though I listed it second. We're going to look at the period first. So the period is given by a formula, so you need to know this formula. But the period of any function represents a horizontal shrink or stretch. And so you can just look at the graph and tell whether it's a shrink or a stretch, but I'm not extremely concerned with you knowing whether it's a shrink or a stretch. I just mainly want you to be able to find the period of a function. And so the period is given by this formula for sine or cosine, 2 pi over whatever b is. And remember, we said b is just this number right here that's in front of x. And so we're going to put 2 pi over b and divide those. Now, if you have b as a fraction or something that's less than 1, then you have a stretch. So it'll stretch it out this way. If b is greater than 1, then you have a shrink. Alright, so I'm going to graph a couple of these functions on the calculator just so you can see what a value that's less than 1 will do and a value that's greater than 1 will do. So in my calculator right now, I've got sine of 1/2 x. And so when I graph this one, you can see that the period's no longer going to be 2 pi. I've stretched this out, and so the period's going to change. Okay, and I'm going to go turn this one off and turn this one back on. And so now if you look at this one, I made this one bigger than 1, and so this is going to end up being a shrink. So it's going to shrink the period down. And so if you look at this graph, you've got a whole lot of little mountains and valleys, and so it shrinks that period down. And so one little mountain valley cycle is not that long. It's not going to take you all the way out to 2 pi. And so that's what we're going to start finding. We're going to start finding the value of how long it takes to make that one full cycle, and that's what we're going to be doing when we find the period. And so I'm going to find the period of these graphs, these three. So for these graphs, the formula, period equals 2 pi over the number in front of x, which is b, and so I'm just going to put that over 4. And so the period is 2 pi over 4, which would reduce to pi over 2. And so I'm going to type this in and show you how that affects the period on the calculator. So let's go clear these out. And so I'm going to type in 2 sine of 4x. And so if we graph this, if I hit trace pi over 2, then it's going to give me the period, or what it would take to make this one little up-down cycle. So it should give me this point right here. So if I hit trace and I type in pi over 2, it does give me that point right there. And so that's how you can kind of check yourself also. Let's go find the period for these. Alright, so then this one I'm going to take the period and put 2 pi over. Now, if there's ever numbers like this, like a fraction in front of this is the same thing as pi over 4 times x. And so you have to take that entire pi over 4 and then flip it and multiply. So this will be 2 pi times 4 over pi, and then my pi's will cancel, and so I'll just have 8. And it's possible to have a period that doesn't have a pi in it. That's fine. And so then this last one, the period is 2 pi over, this is the same thing as 1/2 x. So I'm going to put it over 1/2 and take this and flip it and multiply. So it's going to be 2 pi times 2 over 1, which is just going to be 4 pi. And so then that's how we're going to find the period.